What's going on, guys? In this video we are going to see how to find mesh currents and branch currents using mesh analysis by inspection method. So here we have the steps to find this one using mesh analysis by inspection. The first step is assign mesh currents. So let's name it this one as I1 and let's name this one I2. So we are going to create a mesh in each loop. So this is I1, I2 and this is I3. Right, now let's see the next step. Find resistant matrix elements. So here first thing we are going to do is we are going to find the diagonal matrix. To find diagonal matrix, for example, first R11. So to find this one, what we do is we look at the I1 mesh current and see what are the resistance we have in this loop. And if you look at this one, we have only 20 and 10 in the I1 mesh, right? So we just add them together. So this is going to be just 20 plus 10 and that's equal to 30. And R22, we look at the second mesh. So this is I2, right? I write this one clearly. I2, right? So I2, in the I2, what are the resistances we have? 20, we have 20 right here, 30, and here we have 5. So this is going to be 20 plus 30 plus 5, and if you add them together, that's going to be 55. And the next one we have third mesh, that is R33. And if you find all the resistance inside, that's going to be 10 plus 5 plus 5. Actually, 10 plus 5 plus 5. So this is going to be 10 plus 5 plus 5, and that's going to give us 20, right? So this is going to be 20. So these are our diagonal matrix. Now we have to go for the next step, that is Rij. That is, we have to look at the resistance that is shared by two meshes. And first of all, if you look at I1 and I3, so let's put R13. So whatever the mesh it's shared, we put the number I1, I3. So we put R13, and that's going to be same as R31, right? So just the flip, R31, and we have to look at the resistance that's shared by both. And if you look at this 10 ohm is shared by both, right? Because I1 is going through this 10, I3 also going through this 10. So we have to put 10, but here we have to do one more step, that is we have to put a negative sign. And then I1 and I2 also sharing one resistance. So we have to put R12, and that's equal to R21. And the resistance that's shared by both is 20, so this is going to be just minus 20. And I3 and I2 also sharing one resistance, that is 5, so we put R23 and R32, and that's equal to negative 5. Now we have all the resistance matrices, so we can go ahead and create our matrix. So first of all, so whatever we have here, that's represent the row and columns. This is first row, first column, second row, second column. So first one we found out the diagonal matrix. 1, 1, 2, 2, 3, 3. This is diagonal matrix, right? So 30 right here, and 55 right here, and 20 right here. So this is diagonal. Others we are going to replace according to the places. This is first row, third column. So this is going to be first row, third column right here, and third row, first column. So this is going to be right here, right? So we put this one in two places. And first row, second column, negative 20. Second row, first column, negative 20. And the third one is second row, third column, that is negative 5. And third row, second column, negative 5. Now we have our matrix. So from this one we are going to find I1, I2, I3, and this is equal to, and if you look at the next step, find the mesh voltage, right? So this is mesh voltage is going to be the other side. So what we do is we look at the voltage source in each mesh and put them in each column. Like if it's I1, we look at the I1 voltages. So if you look at the voltage source, this I1 is going through minus to plus, because the direction is like this, clockwise, right? So this is going from minus to plus, that's a voltage rise. So this is going to be a positive 100 volt, and we put positive 100. And if you look at the I2 mesh, we don't have any voltage source. We don't have anything with plus sign, minus sign, or voltage. So we don't have any voltage source. So here we put 0. And the third one also we don't have any voltage source. So that's also 0. Now we are ready to calculate, right? Now, in order to solve this one, we have to definitely use Cramer's rule. Otherwise, no way, right? So here we have to use Cramer's rule. Cramer's rule is basically first we find the matrix, I mean determinant of the original matrix, and the easy way to calculate matrix is going to be this one. You put the numbers minus 10, minus 20, 55, minus 5, minus 10, minus 5, 20. There are different methods. One method is this one. You write the first two terms again, like 30, minus 20, minus 10. Then the last one is minus 20, 55, and 20. So what we do is we cross this one, first three term and last three term. First three term goes in this direction. So the first three terms we cross like this, and last three terms we cross in the opposite direction, like this, right? And this side direction we add them together, and also other side direction we calculate, multiply them and add them. After you add them, you have to subtract this one, like whatever I put red and this pink color. So you put red color first, you put red color. Red color is just you multiply this diagonal, right? You multiply, add them, multiply, add them, multiply, add them, and then use whatever the total values, you subtract this one, subtract this rose color from this red color. So you multiply this diagonal, this diagonal, and add with this diagonal, add with this diagonal. So whatever your value you're getting, you just subtract. So that's one method. And other method is you put plus, minus, plus, and eliminate the vertical and diagonal, I mean horizontal components. There are too many different methods. So you can try that, and if you calculate this determinant, that's going to give you 16,750. And in order to find I1 and I2, I3, we have to have three determinant, right? So first we find the original determinant, and then to find I1, what we do is we swap this one, these values, whatever the voltage value we found, we swap with them, this one with the first column, and our matrix is going to look like this: 100, 0, 0, and others going to remain the same. That's going to be minus 20, 55, minus 5, minus 10, minus 5, 20. And if you calculate the determinant, you will get 107,500. And you do the same thing for the second one. Second one, you have to swap this one with the second column. The first and third column remains the same. So that's going to be 30, minus 20, minus 10, and the second column is going to be this voltage. So that's going to be 100, 0, 0, and the third column remains the same. That's going to be minus 10, minus 5, 20, and then if you find the determinant, you will get 45,000. And for the third one, it's same thing. You swap this one with the third column, and in the third column you are going to have 100, 0, 0, and the other first two columns remain the same. And if you calculate the determinant, you will get 65,000. So from this one we can go ahead and find our mesh currents. So mesh currents is going to be, for I1, what we are going to have is this first determinant, whatever the determinant you found out swapping with the first column, that's going to be the I1's determinant, right? So first one divided by the original determinant, and if you do that, so that's going to be, the values are going to be this one 107,500, and the determinant of this one is 16,750. And if you calculate this one, that's going to give you 6.42 ampere. And I2 same thing, you second equation divided by the determinant, and we found out this one, that's 4500, actually 45,000 divided by 16,750, and that's gonna give you 2.69 ampere. And third also same thing, that's gonna be third determinant we found, right, and divided by the original determinant. So third determinant we found, this is 65,000 actually, 65,000. So 65,000 divided by the original determinant, that is 16,750, and if you find the value, that's going to give you 3.88 ampere. So now we have all the mesh currents. So in case if you want to find a branch current, so let's get rid of this part. So let's say you want to find this current going through this middle part, this bridge, right? So in case if you want to find the current going, let's call this one IB, and in case if you want to find the current going through this one, the equation is going to be I3, because I3 is, if we put this one as our direction, IB, let's say since I don't have space, I put this current here, so this is going through this middle part. If we put this direction, that's going to be I3 minus I2, because this is going along the I3's direction, right? If you put opposite direction, that's going to be minus I3, because opposite of. So here this is along the I3's direction, so this is going to be positive I3, and I2 is going opposite of this direction, so that's going to be minus I2. And I3 we calculated 3.88 ampere, minus I2 is 2.69 ampere, and that's going to give you 1.19 ampere. So this is going to be our IB. And for example, if you want to calculate this, let's say you want to calculate this one, let's call this one I1. So if you want to calculate this current, this one right here, so let's say if you want to calculate this current, this branch current, I1 is going along this direction, so this is going to be plus I1, and I3 is opposing this direction, so minus I3, and I1 we calculated, that is 6.42 ampere, minus I3 is 3.88 ampere, and if you calculate this value, you should get 2.54 ampere. And that's how you do this kind of problems. I hope you guys find this video helpful. See you next time.